Oh shit. I didn't get home until ridiculously late tonight either. So, another day of not getting anything done, but I thought right quick before bed maybe I would try to present. I'm sorry, I'm so tired I can't even think straight. I thought maybe I'd try to present what was going on so far with the data structures and the way things are working. This is our new dungeon data structure. At the top of it, on disk anyway, stored a little differently in memory, but it all loads in about the same way. There's just a unsigned 16-bit number that denotes the version of the file format. So that'll allow us to update file formats as we change the code and add stuff and stuff like that. And we've got, the next thing is 13 bytes, that's 8.1 plus a trailing null character. File name for the dungeon, and yeah, we're sticking with the did I say 8.1? I meant 8.3, like CPM and MS-DOS file names. And that way, you know, using the lowest common denominator, the lowest common denominator file naming scheme like that will be sure that it'll work right on everything. I can't think of any file system that is more restrictive than that, so that should be fine. Following that, we have a 32-byte dungeon name like Telengard or Sphinx Lair or whatever, followed by the level name. In the original game, you know, each dungeon level was numbered. You know, you started on level 1 and you could go all the way down to level 20, and there was that spatial relationship between the dungeon levels. The deeper you go, like the tougher things get and the more loot there is. But as we extend the game later, I want to have like different types of quote-unquote dungeons. Like we could have towers that would start at the ground level and go up. We could have forests where the outskirts of the forest have the least scary monsters, and then as you get into the deep forest, by like moving off the edges of maps, like in directions other than up and down, right? The monsters would get tougher. So we've got a name for the level, and in all the old school like original dungeons, the level name is just like level 1, level 2, level 20, etc. But I put this in here so that we could have like evil forest, comma, outskirts or something like that, right? So that's the reason we have another 32-byte dungeon level name there. Then we have the origin, X and Y coordinates. The reason for this is so that we can grow the size of the dungeon in the editor without renumbering all of the dungeon locations. So we can have negative, see this is a signed 8-bit integer, so we can have dungeon locations ranging from negative 128 to positive 127 in the X and Y axes. And the default origin will be 0, 0. But, you know, if we want to extend the dungeon to the west or something, then we'll have to, you know, move things over. And the reason that I don't want to renumber the whole dungeon, because of course in C arrays always start at 0, right? That's why we have these two origin variables here, so we can kind of offset that. The reason what was I talking about? Shit. I'm so sorry. The reason we don't want to renumber the dungeon locations is because some of the special features, which we'll get to in a little bit, they'll be referencing like locations in the existing dungeon level or other dungeon levels or like anywhere by X and Y coordinates. So like if we've got like a stairway, for example, that transfers the player character from one map to a specific XY location on another map, and then we, you know, expand that other map, we don't want to renumber everything, or we have to go back to that other map that we just came from and like change the data within the staircase on that map, and it'll turn into a buggy mess. So as long as with these origin coordinates here baked into the dungeon file format, we'll never have to change the the numbering of the dungeon locations, and it will make things much less bug prone, I think. And then of course we have the width and the height of the dungeon. The original old school dungeons were 20 by 20. I think, yeah, I've got it set to right now support a maximum dungeon size of 32 by 32. That's 1K. I think that's for the walls. I mean, that's perfectly doable within a 64K 8-bit system. I think so. That should work fine. Now the walls, of course. Instead of being 4 bits, 2 bits each for the north and west walls, I've expanded this to an unsigned 8-bit integer, which gives us 4 bits for the north wall and 4 bits for the west wall. So that means that while the original game had 3 different possible walls, not including no wall, with this format we have the possibility of 15 different walls. And the reason I want to do this is because I want to have locked doors that can be opened with different types of keys, and probably other things too. So that gives us room to grow into the future with the game. Now then we get to the dungeon special features. This is like the pits and the altars and like the fountains and stuff, the shit that you come across in the dungeon and interact with. And in the original game, this was baked in with the walls. It was all stored in an 8-bit integer, so four of those bits were used for walls, so there were 4 bits left for whatever special feature was in that location, which gave us in the original game, possible number of dungeons, 15 possible, geez, I can't keep my head on straight, 15 possible special features in the dungeon. And we'll get into this later, but right now I'm encoding the special feature type into an 8-bit integer, so theoretically we could have 255 different dungeon special features, but in reality, if we actually tried to add that many, the code to handle each of those special features would probably exceed the memory size of like an 8-bit system. That would be doable on like a 640K IBM PC or something, maybe. I don't know, maybe that'd still be pushing it too. But on like a Z80 or 6502, there's just no way we could actually have 256. But I do want to be able to go on past the original 15 dungeon special features. I want to have like levers that you can pull, and since special features now have like a little data segment that they can define like their own like little data in, that gives us the possibility of having like levers that open and close pits or lock and unlock doors. So that I think that'll make it make us able to make the dungeon levels much more interesting, like puzzly. You know what I'm saying? Like more like you might find in like Eye of the Beholder, where you have to like figure some stuff out before you can get down to the next dungeon level. I think that'll be a lot of fun. The thing is though, like I said before, in the original game, each dungeon location was stored in 8 bits, and 4 of those bits were the dungeon special feature. And most locations within the dungeon had no dungeon special feature. Like the first level of Telengard contains 400 different locations, but I think there are only 26 different dungeon special features. So that we're wasting a ridiculous amount of memory that way. So instead, what I've done here is I've just defined this block of bytes, which is currently 1K, and that's like, I'm treating that like a heap, like a miniature heap that's pre-allocated by the compiler here when we define our master dungeon structure, right? And then I'm doing some pointer funny business to pack the dungeon special features into this like mini heap, and this is where shit gets a little real. Maybe see, I'm one of those guys that kind of enjoys complexity for complexity's sake. So maybe I'm making things too weird here, but it is, in my opinion at least, very interesting. So within this 1K heap defined within the dungeon structure, we have a number of these special feature structures, and each special feature has a unique ID between 0 and 255. That's so that we can look up. We can have dungeon special features that do something to another dungeon special feature. Like I was talking about those levers before. Like if we define like a lever dungeon special feature at a certain dungeon location, and then when you pulled that lever, part of that lever's data block, which we'll get to in a second, would contain the 8-bit ID of the door or the pit or whatever that it was supposed to be opening and closing, and based on that, it could fetch, not necessarily fetch, it could go to the correct place in this heap to set the other special features data block, some element within its data block, like denoting whether the pit was open or closed, or whether the door was locked or unlocked. You know what I'm saying? So there is it's not an array of these though, because we define the ID, we define the X and the Y location of the special feature within the dungeon. We define the type of special feature that's used to look up which piece of code that we're supposed to run when the player interacts with that special feature. And then there is the length of this particular special feature's data block, which can be 0. And if it is 0, then the next thing in that little heap is just another one of these structures. But if it's non-zero, then immediately following this structure within that little heap here is a number of bytes of this length that we can cast to whatever particular structure pointer the particular type of dungeon special feature uses to interact with its data, right? Clear as mud so far. I'm sorry. These are the functions that we use to interact with to deal with this heap of dungeon special features. And the reason we've just piled them into a heap like this is because they're all packed in there now, and we're not, wasting 4 or 8 bytes for every dungeon location, even when there's no special feature there. So when the player moves locations, it'll go through this whole block, and since we know the data length, it can loop through them very fast and just compares the X and Y locations until we find the first special feature at a particular location, and then we'll branch to the function that lets the player interact with that special feature, right? And yes, indeed, this does mean that the way this structure is set up, we can have more than one special feature in a particular dungeon location. And the way that'll work, I think, is that the function that handles the interaction with the special feature, it can return, when the player's done interacting with that special feature, it can return true or false, which will tell the game engine whether or not it should move on and process the next dungeon special feature. And I think that'll be useful for stuff like flavor text, and especially in conjunction with this data block, so we can track whether a special feature has been visited or not. This will allow us to, as you move around the dungeon, it'll be like it can display text describing this part of the dungeon, like the first time you go through it. Maybe it'll be more detailed, and then when you visit it subsequently, there'll just be something a little shorter It can describe like, oh, it's very foggy here. There's a breeze coming from the west to clue you in on a secret door, or whatever. I think that'll make the dungeons much more immersive and more tabletop-y. I think that'll be cool. So anyway, we've got these helper functions to help us deal with this heap of this heap of special features here. Of course, they're all defined in this header, but here they are. So first of all, there are a couple of functions here to deal with the entire list, and this is mostly used by the editor and loading and saving dungeons. Like for someone who's like designing a dungeon level for the game, these won't be nearly so useful. But anyway, you call this first one, it just gives you the first special feature in the dungeon, regardless of its XY location, just the first one in this heap. And then you call this next function, passing it the previous special feature that you looked up, and it moves on to the next one. It calculates the beginning of the next special feature within this mini heap, based on the size of the special feature struct and the length of the data that follows it. And this is where I was having that fascinating bug yesterday, because I'd forgotten how pointer arithmetic works in C because I'm a dumbass. So doing stuff like this outside of an array is illegal. But since we're emulating like a little mini heap with an array of bytes, we can do this without fear of screwing the pooch. All right. So normally, if we have a pointer to a particular struct, all right, if we add 1 to that pointer, it actually increments the pointer by the size of that particular struct. So it treats that pointer like an array, right? Which is obvious when you stop and think about it, but I forgot, I guess, that this was the case, and I had these huge bugs because this isn't an array. This is just a heap of bytes, right? And all I had to do to fix this fucking bug that I spent like 3 hours trying to track down was to cast to a void pointer here, so that it only adds 1. So it only adds 5 to it. That's the size of the special feature struct, instead of incrementing it by 25, 5 times the size of it again. You know what I'm saying? So that was really stupid of me. I guess I've forgotten how to write code. I don't know. But anyway, yeah, this looks ugly as fuck, and I'm sure you're scratching your heads. But if we were planning on targeting larger systems and not wanting this to run on like 64K 8-bit systems, we'd probably do something that was a little more memory intensive. But I've got to do this funky pointer arithmetic bullshit because it is a little bit of premature optimization, but if we want this to run on 64K machines, this is going to be the most processor and memory intensive part of the game engine, dealing with these special feature lists, I think. And we can save a whole lot of memory and then use that memory to make the game more immersive. But we have to go into it with targeting 64K systems in mind. So yeah, it looks gnarly, but we're just using pointer arithmetic to calculate offsets into this mini heap is all this is. And yes, I know I need to document this better. I've been rushing, trying to get this done by the end of the month, which means not commenting shit how I should. So I'm sure I'll forget how it works and go back to it and have to do a lot of head and ass scratching to figure this out again with these. Anyhow, I remember how we were talking about how each special feature has a unique ID. We just have a function that looks up a special feature in the dungeon by its ID, and it just runs a loop using these two previous functions until it finds the one. Easy peasy, right? Same with getting the first special feature at a particular XY location, and then iterating through and getting the next one at a particular location. Creating a special feature, since we have the length of the data block on disk stored in the dungeon structure here, we can just append new special features to the end of this heap, and then add to the heap size variable right here, the size of the heap, the number of bytes that are used within that heap, I should say. And that doesn't take into account moving special features back and forth within the list. That's something that I need to implement. There are several things I still need to implement, but that's something else I'll need to implement for use with the editor, because of course special features that occur closer to the head of the heap will be the ones that the player interacts with first at a particular dungeon location. So I need to have functions in here that will remove an entry from the heap and then either move the whole heap down and stick it at the beginning, or place it at the end, so that we can send stuff to the head or the tail of the heap, so that we can change the order in which the special features are processed when the player interacts with them. Right, so moving on to the dungeon code, there's not all that much to it. I am keeping track of byte order when we load the dungeons from disk. The 6502 and the Z80 and Intel CPUs are all little Indian, so this strictly isn't necessary. There aren't very many big Indian CPUs still in use, I think. But ARM is little Indian, I think, right? The Motorola 68K is big Indian, and the PDP-11 is little Indian. The PowerPC is little Indian, but the bytes are in a reverse order, or the bits are in reverse order in bytes or something like that. I can't remember. I've never actually coded for the PowerPC. I recall there being something really fucking strange about the PowerPC, and that's why I still have these byte order swapping functions for 8-bit data types, just in case I need to do some reversing magic. Those, of course, are defined in the platform code, like anyway. So yeah, and then we just have functions to load and save dungeons to disk. The load function isn't working right now. There's a bug in there somewhere. It was dumping core, as I recall, or something was wrong. I need to look into that. Or maybe I fixed that day before yesterday. I can't remember now. It's too late to think. Anyway, so yeah, oh, that's just a map I was looking at. So yeah, we're moving along. It's a shame I didn't get any work done on this evening, but quite frankly, I'm too whipped to try to do stuff that requires cogent thought, so I'll try to get back to it tomorrow, I guess. Alright, thanks for joining me. I hope this wasn't too ridiculously boring, but please, if you have any comments on any of this, even if you want to make fun of my shitty code, especially this kind of bullshit, please do comment. The whole reason that I do this stuff and make the videos about it is because I don't have any like real life old computer buddies. So the purpose behind all of this is to interact with you guys. So yeah, leave comments and tell me what you think. Make fun of my shitty code. Give me some suggestions if you want to, or whatever, man. Whatever. Alright, cool. Okay, bye.